Hey everyone, have you ever just looked around your room or outside and had that big thought pop into your head? What is all this stuff actually made of? Well, today we're going to be detectives. We're on a mission to find the one single answer that connects absolutely everything. Let's get into it.
Just look at all this stuff on the screen. A rock, a pen, some keys, a cricket ball. I mean, they couldn't seem more different, right? But what if I told you they all share one huge secret? There's a fundamental connection between every single object you see here. Stick with me, and you and I are going to figure it out together.
All right, so here's our game plan for this journey. First, we'll look at objects and the materials they're made of. Then, we'll act like scientists and group things by their properties. After that, we'll test some of their special powers and uncover two secret properties that everything has. And that's all going to lead up to the big reveal. What is matter? Okay, first things first. Before we can understand what everything is made of, we kind of have to start smaller and look at what individual things are made of. And that brings us to the most basic building blocks of our world, objects and materials.
So what even is a material? Well, it's actually super simple. A material is just any substance that we use to make an object. Like the book is made of paper. A chair could be made of wood or maybe plastic. That window you're looking out of, it's made of glass. So paper, wood, plastic, glass, those are all materials.
And here's what's cool. This whole thing is a two-way street. You can have one single object, like a pen, right? And it's made of a bunch of different materials. You've got plastic for the body, metal for the little tip, and then the ink inside. But you can also take just one material, like wood, and make tons of different objects. A table, a chair, a pencil, a door. You see what I mean?
Okay, so we've got all these different materials out there. How in the world do we even start to make sense of them all? Well, scientists basically play a game. They sort things into groups by looking for clues, and these clues are called properties. Honestly, it's kind of like a scientific version of I Spy. So our very first clue is all about how something looks. The first question we ask is pretty simple. When you look at a material, is it shiny or is it kind of dull? This shininess property has a scientific name, luster. So materials that are shiny, like a metal spoon or maybe a gold ring, we call those lustrous, and materials that aren't shiny at all, like a piece of paper or a block of wood, are non-lustrous. Really, luster is just a fancy science word for how shiny something is.
All right, next clue in our game of I Spy. Let's move on from how it looks to how it feels. Can you squish it? Can you scratch it easily? In other words, is it hard or is it soft?
Now this one's pretty easy to get. Hard materials, like a stone, are really difficult to press down on or scratch, but soft materials, like a sponge or an eraser, are super easy to squeeze or leave a mark on. But you gotta remember, it's all relative. A rubber ball is obviously softer than a piece of iron, but it's way harder than, say, a cotton ball. Now that we've got a handle on luster and hardness, let's put on our lab coats and test some other really cool properties, or, superpowers that materials have. It's time to run a couple of simple experiments. For our first experiment, I want you to imagine we're all playing a game of hide and seek. Now, where you decide to hide totally depends on the material you're hiding behind, right? And this is actually the perfect way to understand how well light passes through different stuff. So, think about it. If you hide behind a big wooden door, nobody can see you. That's because wood is opaque. You can't see through it at all. Now, what if you hide behind a frosted glass door? Someone might see your blurry shape, but they can't see you clearly. That's translucent. And, well, if you try to hide behind a crystal clear window, that's a terrible hiding spot, because glass is transparent and everyone can see right through it. Yeah, and this slide shows that difference perfectly. You see on the left, that opaque wood completely blocks our view. No light gets through. But on the right, the transparent glass lets all the light pass right through, so we can see everything behind it perfectly. Okay, experiment number 2. And this is one I bet you've done in the kitchen. What happens when you take different things, like maybe sugar or a spoonful of sand, and you try to stir them into a glass of water?
Well, you know that some things like sugar or salt, they just seem to, poof, vanish. They dissolve completely. We call those materials soluble. But other things, like sand or maybe chalk powder, they just sink right to the bottom or make the water all cloudy, no matter how much you stir. Those are insoluble. So it's simple. Soluble disappears, insoluble sticks around.
So we've looked at a bunch of different properties: shiny, hard, transparent, soluble. But not everything has these properties, right?
A rock isn't transparent, sugar isn't all that hard. But now we've reached the most important part of our investigation. We're about to uncover two special properties that absolutely everything has, no exceptions.
Okay, first up, everything takes up space. I know, it sounds so obvious we don't even think about it, but if your friend throws their school bag on a chair, you can't sit there, can you? Why? Because the bag is taking up that space. And the scientific name for the amount of space something takes up is its volume.
And what's the second property that everything shares? Well, every object has some amount of stuff inside it that gives it weight. A bowling ball is way harder to lift than a beach ball because it has way more stuff in it. The scientific term for the amount of stuff in an object is its mass. So usually, things that feel heavier have more mass.
So we did it. We found the two secret clues that connect every single object we saw at the beginning. Everything has mass, and everything has volume. And that discovery leads us right to the final grand reveal, the answer to our big question.
Let's just put it all together now. Every single thing that we can see and touch has mass. It has some amount of stuff in it. And every one of those things also has volume. It takes up space. So, what do we call anything that has both of these properties?
We call it matter. That's it. That's the big secret. Anything, literally anything that occupies space and has mass is called matter. That rock, that ruler, the water in your bottle, the chair you're sitting on, even you. It is all just different forms of matter. That's the word that connects everything in the entire universe.
So let's do a super quick recap of everything we just figured out. All objects are made of different materials. We can sort those materials by their properties, like if they're shiny or hard or see-through. But the two most important properties that all materials share are mass and volume. And the biggest takeaway of all, anything that has mass and volume is called matter.
And now I want to leave you with one final thought to chew on. What about air? I mean, we can't see it. We can't really feel it unless there's a breeze. So based on our brand new definition, does air take up space? Does it have mass? Is air matter? I'll let you think about that one. Thanks for joining me on this awesome scientific mission.